So this is the second one of these we're doing just because I wanted to make sure that you had a little bit of practice, but we're trying to figure out whether or not salts are acid or basic. And the real key here is, do you understand your conjugates? Do you understand which things are conjugates of strong acids and which things are conjugates of strong bases? Because anything that's not a conjugate of a strong acid or a strong base will impact whether or not the ionic compound is either acidic or basic. Now, if you don't know these very well, I encourage you to go back and watch the solubility rules video and have the pretty rules next to you as you go through this. But if we take a look at these, there's a couple of general rules here. One is we take each of our ionic compounds and we break apart them into their individual parts. We have NH4 plus, and here we have Br minus. Now, essentially what we're going to do is we're going to see, is this the conjugate of a strong acid? And the way we do that is by putting an H in front of the Br. Now, if you take a look at this HBr is for sure a strong acid. And remember from CBS pin, this is the B in the CBS pin. Therefore, this is going to be a pathetic conjugate, which has no ability to do anything. So the Br right here, we're just going to write on top of that neutral. Now, NH4 plus, it is the conjugate of NH3, and it's kind of important in this sense that this right here, no matter what, if you were to put an OH on the end of it, right? If you were to put an OH on the end of that, would that make this a strong base? And the answer to that is no, it wouldn't be a strong base. Therefore, this is going to be a weak acid. So what we have over here is we have a weak acid and we have a neutral conjugate base. Therefore, what are we going to be? We're going to be overall acidic. And we're going to do the same exact thing when we look at Al and NO3. Now, I'm just dealing with the actual ions, Al3 plus and NO3 minus. And remember, there are three of these because they're bouncing off the minus with the 3 plus. But what we're going to do is we're just going to see whether or not these are acid or strong acid or strong base conjugates. And the way we can do that is by putting an H in front of this NO3. And when we do that, is this a strong acid? And the answer is yes, it is. What does that make this? It makes it pathetic. It means that it's going to be a base that literally cannot grab any hydrogens or do anything. So we're going to write this on the top here as neutral. Al3 plus, let's just go to the go-to rule. If you ever have a transition metal, transition metals are always weak acids. Always. But if you wanted to verify, you could put that Al in front of OHs, right? And if you put the Al in front of the OH, is this AlOH in parentheses 3, is that a strong base? And the answer is no. Therefore, this would be a weak acid. So over here, we have another weak acid. So we have an acid and neutral that makes this acidic. I don't know why I'm doing multiple colors, but that's just how it is. And then finally, we're going to take a look at the Na and the CH3CO2, which is acetate, by the way. And if I take a look at that, I have Na plus and I have Chku. I like to write it like this. Yeah. So what are we going to do? We're just going to put an H with this, and we're going to put an OH minus with this and see whether or not they're strong acids. So if I put this together and I wrote HCH3COO, in reality, wouldn't this H really be over here? Is that a strong acid? Is that part of CBS pin? No. Therefore, this right here is a weak base. So we know this is a base. And then we look over at Na, and we should become familiar with this already. It's not a transition metal. It's part of one strong Calbert. Again, if you don't know this reference, watch the solubility rules video. Probably the best solubility rules you can find. And this right here is going to give you NaOH, and that is a strong base, which means this is the conjugate of a strong base, which means that this is neutral. So if we have a base and a neutral, this is going to be basic. Hopefully this has been helpful.